Good afternoon. Now we will see the clauses which are related with IS 456. Now we will go one by one, that is as per code, so that it becomes easy for us to keep in mind the pages. So now generally many times first question that was asked, what is the name of code? So students are always saying IS 456 2000. 456 is number and 2000 that is year of publishing or implementation. Now need not require that is in Marathi language, but you should have Indian standard, and this is important one which you have to say as a name, plain and reinforced concrete code of practice. This is name of IS 456, plain and reinforced concrete code of practice. Means this code we are going to use for plain concrete also, for reinforced concrete also, and that is in practice. So simple name, plain and reinforced concrete code of practice, published in 2000. Now this question generally asked, the that we will see characteristic strength when we will go to limit state. So now the minimum grade of concrete for plain and reinforced concrete shall be as per table 5. So we have to go to table 5, and this table that is given on page number 15. And here they have mentioned plain concrete, minimum cement content is given, maximum free water cement ratio, minimum grade of concrete. And you can see we have this minimum grade of concrete that is M15. And the exposure they have mentioned over here. So if we have severe, moderate M15, severe M20, very severe M20, and extreme we have M25. And if you will go to reinforced concrete, then we have minimum cement content, maximum free water cement ratio, and these conditions are applicable to reinforced concrete. For mild, we have M20. For moderate, M25. Then we have M30 for severe, M35, and then for extreme, we have M40. So minimum for plain concrete is M15, and minimum for M20, minimum for reinforced concrete is M20. This is given on page number 15. Then we have tensile strength. So not required actually for RCC, but may asked. So we have FCR, that is flexural strength of concrete, or cracking strength we can say is 0.7 root FCK, and FCK is characteristic cube compressive strength. Sometimes they ask what is FCK. This is cube compressive strength, and cube generally we have 150 by 150. Now modulus of elasticity we have 5000 root FCK, and E suffix C is short term static modulus of elasticity. So modulus of elasticity for the 5000 root FCK, and FCR 0.7 root FCK. The tolerance, these are given on page number 16 of IS 456. So tolerance is on placing a reinforcement. So may ask what is tolerance in placing of reinforcement, and we have plus minus 10 up to 20 mm effective depth, and plus minus 15 up to 200 mm effective depth. Then dead load. So already we have seen, we have IS 875 part 1. We have that is dead load. Now the main students are not in position to answer unless more accurate calculations are wanted. The unit weight of plain concrete. So keep in mind, plain concrete we have 24 kilonewton per meter cube, and reinforced concrete we have 25 kilonewton per meter cube. So we have difference in plain concrete and reinforced concrete. So do not tell concrete we have 25. We are using 25 because we relate with reinforced concrete. But if you have plain concrete, then you have to consider it as 24. So then we have imposed load. So already we have seen imposed load. We have IS 875. So IS 875, we have that is part 2. If we will go to wind loads, then we have part 3. So we have mentioned over here. So we have IS 875 part 2. This we have for imposed load. They have mentioned over here. So imposed load IS 475. We have wind load and snow loads. So wind load we have IS 875 part 3 and snow loads we have IS 875 part 4. So imposed load, wind load and snow loads. Part 2, part 3 and part 4. Earthquake load sometimes may ask, do you know? So we have 1893 which is for earthquakes. And combination of loads, these are given in IS 875 part 5 which gives us all combinations of load. And all these clauses, these are given on page number 32. In first some videos, I am going to only show the clauses which we are used in IS 456 directly or indirectly. Then arrangement of loads. So consideration may be limited to combination of. Now you can see what is first dead load on all spans. So dead load is always there. So design imposed load on two adjacent span. So keep in mind, dead load on all spans and design imposed load on two adjacent spans. This condition is for maximum support moment. Maximum support moment. So we have to keep in mind whenever we will have two adjacent span with total load and then we have alternately only dead load, then we have that condition is maximum support moment. Means if we will plot it, and then if we are interested to find, so dead load is always there. So we have this as dead load. And now if you have to find value that is maximum support moment, then we have maximum support moment. Suppose if I will say this will be B, then we have to keep live load on BC, AB and BC. If you want on C, then you have to put BC and then you have to put CD. And generally support A and support D, we are considering as simple support and therefore we are assuming bending moment over 0 over A. So we have adjacent span to the support, means we have support B. Now we are interested with support B maximum moment, then we have to put on AB and BC. And that is your first condition. Second, design dead load on all span with full design imposed load on alternate span. Means we have to, this is for maximum span moment. Maximum span moment. Means if I am interested with maximum span moment in AB, I will apply live load on AB and live load apply on CD. So automatically, though I am applying for AB, my condition for CD also satisfied because they have mentioned over here on alternate span. So automatically your condition of alternate span also satisfied, means AB we will get maximum span moment, CD also we will get maximum span moment. So alternate spans maximum span moment condition is satisfied by using this. Now, when design imposed load does not exceed 3/4, now this question may be asked. If you will go to your files, then your imposed load, that is live load, is less than 3/4 of dead load. In most of the condition, we are with this. And then what they are saying, the load arrangement may be design load and design imposed load on all spans. So he may ask, if you are in this fashion, then why you have used these conditions? So that is most important. You should know what is given in note. In note, they have mentioned for beams and slab continuous or support, 22.4.1a may be used. Means for beams and spans, we have to use only these two conditions. We will not go for this. Otherwise, our this condition is satisfied, and we have on all spans, that is dead load and that is live load. But due to this note, we are not going to use this condition because we are going to design beams and slab, and therefore we have to go for these conditions for maximum support moment and for maximum span moment. This is given on page number 35. So we are now stop here only. Remaining part we will see in the next video. Thank you.